This is the next video, and this video is about the second order differential equation, also known as second order ODE. And the linear equations the equation which I will describe is linear second order differential equations. So what I will discuss in this video is a general form to write the second order linear equation, and what are homogeneous second order linear equation and non-homogeneous second order linear equation. So a first order linear equation was something which was written in the form like dy by dx plus p of x y equal to q of x. This was a first order differential equation which was of course linear. So here p of x and q of x are function of x. Now the next thing is, when you are talking about second order differential equation, these are the equation which can be written in the form of d square y upon dx square plus p of x into dy by dx plus q of x into y is equal to r of x, where p, q and r are functions of x. So the big thing here is that if r of x is equal to 0, then this is my homogeneous second order linear equation, while if r of x is not equal to 0, this is a non-homogeneous second order linear equation. So again, if I am writing my dy by dx is equal to y dash and d square y by dx square is equal to y double dash, then this can be written as y double dash plus p of x y dash plus q of x y is equal to r of x. So just taking examples, if I have an equation like y double dash plus 5 of y is equal to e raised to x, then this can be, if I am considering the standard form, my standard form is y double dash plus p of x into y dash plus q of x into y is equal to r of x. So if I am considering this form, my p of x is equal to 0 here, and my q of x is equal to 5 here, and my r of x is equal to e raised to x here. So considering the same thing, what you are getting is, considering the same way, what you're getting is that your y double dash, this can be written as y double dash plus 5y is equal to e raised to x. This is a non-homogeneous second order linear differential equation. Well, considering the same case, if I'm having an equation which can be written as y double dash plus e raised to x y dash plus 5y is equal to 0. So considering another example, if this was my example 1, this was my example 2, then if I'm considering it with if this was an example, so standard form, which is this, then my p of x is equal to e raised to x here, my q of x is equal to 5 here, and my e r of x is equal to 0. So this is my homogeneous second order linear equation. So it's possible that linear equations will have solutions. So a linear equation, second order differential equation, if I'm considering it in the form of y double dash plus y dash y is equal to 0, then a value of y is equal to a function of x which satisfy this equation can be called a solution. So if I'm having this equation and if I'm taking my y is equal to e raised to minus x, then my y dash is equal to minus of e raised to minus x, and my y double dash is equal to e raised to x. So y dash is equal to d by dx, which is equal to d of e raised to minus x by dx, which is differentiating, and y double dash is differentiating it 2 times. So if I'm substituting it, minus of e raised to minus x plus e raised to, or plus e raised to minus x and minus of e raised to minus x, then what I will get is 0. So I can say that y is equal to e raised to minus x is a solution of this linear or second order differential equation. So again, when you are dealing with these kind of problems while second order differential equation, if you are preparing for your exams, then you will face something like the initial value problems. You'll have to solve the initial value problems. Then what you will find is you'll also have to solve for what is known as your general solution, particular solution, etc.